So collisions can happen very often and in many different ways. And so take a look at these carts that we have. These sides are normal, and so when they hit each other, they're going to move separately in different directions. But the other side has Velcro. So when these two carts hit each other, then they'll move together as one cohesive item and stick together. So we're told in physics that energy and momentum are usually conserved, but is that true? Well, today we're going to find that out. So we're going to do an experiment where we first have these two carts collide with the non-Velcro sides, and then we'll switch it around with the Velcro sides and see what happens to the position and the velocity, which are going to be tracked by these devices right here.
The devices that we are using to detect the velocity of the carts use ultrasound to determine the position and speed based on the time it takes for a sound wave to hit the cart and return back to the sensor.
So let's do it. We're gonna hit the collect data thing, see how this goes, and we'll see how that goes. Alright, so we did that. And now we're going to switch it around. Wow, we love high school. We're going to switch it around now. And then we are going to collect the data once more, once this is perfectly on the track. Great. Then we'll hit collect again. And as you can see, they stick together.
The graph will help us gather the data we need to see if energy and momentum are conserved. There are a couple important things to note when it comes to this graph. The two colored lines represent the two carts. We start with the initial velocities of each cart as shown by the horizontal line. As we can see, there is a change in slope that forms a plateau on both sides. This is the collision between the carts. Finally, the velocity of both carts decreases down to a steady value once more, a value that is different from the initial velocity. We need to take the mean and standard deviation of the initial and final velocities before and after the plateau to help us solve for initial and final momentum of the carts, as well as to look at uncertainty. This involves multiplying the mass and velocity of each cart at both initial and final values. We next add the initial momentums of both carts together and final momentums of both carts together, each representing one side of the equation. We can finally see if the momentums are equal prior to and following the collision. Now that we have all the data, we will be comparing the left and right sides of the equations for energy conservation and momentum conservation for both the elastic and inelastic cases. We will also be using the uncertainty given by the measurement devices to give a range of answers for both sides of each equation. Looking at the equations, we can see that in both the elastic and inelastic cases, the left and right sides of the energy conservation and momentum conservation equations are not equal within error bounds. This is because of experimental errors like friction, air resistance, the track being on a slight slope, and similar limitations. However, in 3 of the cases, they are relatively close, and in one case, they are significantly different. The case in which the sides of the equation are significantly different is that for the conservation of energy for the inelastic collision. This is because energy is not actually conserved in the inelastic collision. Part of the energy is used up in creating the bond between them, causing them to stick together.